Hi everyone, it's Nico here. This is a 3-minute summary of our paper on CSCha circumbinary disk observed with ALMA. CSCha became very famous back in 2018 because there was a detection by Christian Ginsky et al. In the same year. Using Hubble and using BLTs, they were finding this companion here in the outside, which was thought to be a planetary mass companion. So we went and we followed up with ALMA, and sadly, we do not detect anything at that location. So you can see that there's no millimeter emission, just continuum, not in the 12CO, but we do detect the emission from the circumbinary disk, and this is a very deep observation. So our detection is very nice, both in the 12CO and the 0.9 millimeter dust, and you can see that they peaked at different locations. And that's fine because the 12CO is probably tracing the cavity edge because it's very optically thick, so it's tracing temperature, and the highest temperature is at this location. And then the dust continuum emission is tracing the density at the midplane at first approximation, of course. And so what we do is that we go and UV model the dust continuum emission. We find that the best model is a model that has a variable eccentricity as a function of radius. So here you see that we find for the inner radius an eccentricity of 0.04, and then for the outer part is something like 0.02. This is still very circular for a circumbinary disk. So for reference, for example, the eccentricity of the Earth is 0.017. So what we were expecting was something much higher. For example, here you have some simulations of circumbinary disks without planets in the upper part and with planet in the lower part. So you can see that without planet, independently from the binary eccentricity, the cavity is always eccentric and it precesses. Well, when a planet is included, this is much more circularized. And actually, we can quantify this in the paper. Here, so you can see that for two different aspect ratios, the eccentricity of the cavity is always higher when a planet is not included. When the planet is in there, the planet circularizes the disk. Now, there's another interesting result that the planet does not really change that much the cavity size. And so the cavity size is not a good tracer for planets in these disks. Now, the low eccentricity is not the smoking gun to detect planets in circumbinary disks. You can achieve very low eccentricities without the need of a planet. However, it seems to be that the low eccentricities and the axisymmetry is only achieved when you have a giant planet in the cavity. And those are two properties that we do observe in CSCha. So we propose that there's a Saturn mass planet possibly in there. And this Saturn mass planet would actually be located at the edge of the gas cavity. So if you want to know more, please check the other video, check the draft, and also check my webpage, nicolaskurtovich.com, if you want to know more about what I do. Thanks.